In the rural parishes of Småland and Dalarna, nestled within the Swedish countryside, wooden cottages have stood resilient for over 200 years. Among the rustic charm of these homes lies a remarkable invention that has kept families warm through the harshest winters, an unassuming but ingenious structure known as the Röpiss. This tall plastered brick design, roughly 3.5 feet wide and 7 feet tall, has an exterior that appears simple and unadorned, yet it embodies centuries of engineering ingenuity. Subscribe and comment for more nature videos. The Röpiss, often referred to as the poor man's tile stove, has a long history of effectiveness, burning significantly less wood than modern fireplaces, while providing warmth for an entire household. As temperatures outside plunge to -22 degrees Fahrenheit, the Röpiss continues to radiate heat, utilizing a design that captures over 90% of its fuel's energy, a stark contrast to modern fireplaces that capture less than 15%. This text explores the inner workings of the Röpiss, its historical context, the reasons behind its decline, and its potential resurgence in the modern world. When you stand before a Röpiss, you may be struck by its unassuming appearance. It is a rectangular column, constructed of brick and plastered over with a rough coat of clay mortar, standing proudly in the corner of a one-room cottage. The surface may be a matte, uneven texture, with some examples whitewashed and others darkened by years of radiant heat cycling through the masonry. The typical Röpiss stands about 7 feet tall, approximately 3.5 feet wide, and 2 feet deep, weighing between 1,100 and 2,200 pounds. At the base, there is an opening for the firebox, which interestingly is often without any doors. The firebox is designed to be open, allowing users to load wood, light it, and observe the flames without obstruction. This design leads to a crucial difference between the Röpiss and modern fireplaces. In a conventional open fireplace, hot gases rise directly up and exit through the chimney. This process is inefficient. The heat escapes almost immediately, and the chimney acts like a vacuum, pulling heated air out of the house at a staggering rate. In contrast, when smoke and hot gases leave the firebox of a Röpiss, they enter a system of internal channels known as rör, Swedish for tubes or pipes. These channels snake through the brick mass of the stove, guiding the hot gases on a circuitous route, up one channel, down the next, and so on. In a standard 5-channel system, the hot gases travel roughly 33 feet through the interior of the stove before finally reaching the chimney. By the time the exhaust exits the building, it has surrendered almost all of its thermal energy to the surrounding brickwork, leading to a chimney exhaust temperature of 200 to 400 degrees Fahrenheit, far lower than the 1,000 degrees Fahrenheit exhaust typical of conventional fireplaces. This efficiency means that a Röpiss captures and retains heat rather than allowing it to escape. The story of the Röpiss is deeply intertwined with the history of Sweden and its energy needs. In the early 1700s, Sweden faced a severe energy crisis exacerbated by the Little Ice Age, which brought longer and harsher winters. Simultaneously, centuries of deforestation had depleted the once abundant timber resources, straining the ability of households to heat their homes effectively. By the mid-1700s, the Swedish government recognized the impending resource disaster caused by excessive wood burning. Households relied on wood fires for warmth, and the inefficient stoves and fireplaces in use at the time wasted a considerable amount of heat. In 1767, King Adolf Fredrik commissioned architect Carl Johan Kronstad and General Fabian Reiter to design a stove that would use less wood. Their solution was the kakelugn, a tall cylindrical tile stove featuring a system of 5 internal flue channels that forced smoke to travel through the masonry before exiting the chimney. The kakelugn was 8 times more efficient than the open hearths it replaced and quickly became a status symbol among wealthy households. However, the kakelugn was expensive. For peasant farmers living in one-room log cottages, the cost was prohibitive. Resourceful as ever, They stripped the technology down to its essentials, retaining the 5-channel flue system and the enclosed firebox, while discarding the costly ceramic tiles. They used local bricks and clay mortar to construct a stove that looked different but functioned almost identically to the kakaloon. The Röpiss became a staple in rural Swedish homes, offering a solution to the energy crisis while providing warmth and comfort. For the next 200 years, these stoves heated cottages throughout the countryside, adapting to the needs of the people who relied on them. To truly appreciate the Röpiss, it's essential to understand how it operates and the principles that govern its heat transfer capabilities. The materials used in the construction of a Röpiss, brick and clay mortar, are classified as high thermal mass materials. This means they can absorb heat slowly, store it efficiently, and release it gradually. When a peasant farmer in 1780 lit a fire in the Röpiss, the enclosed firebox and channel system created a strong draft that pulled air through the combustion zone at high velocity. The wood burned at temperatures between 1,500 degrees Fahrenheit and 1,900 degrees Fahrenheit, producing a significant amount of heat in a short period. After 2 to 2.5 hours, the fire would typically be out, but the Röpiss would continue to radiate heat into the room for an additional 12 to 20 hours, depending on its size and mass. This meant that one fire and one load of wood could provide warmth for an entire day and night. The Röpiss operates on the principle of radiant heat transfer, which differs significantly from the forced air heating systems commonly used today. When a modern furnace blows hot air into a room, the warm air rises to the ceiling, often leading to temperature stratification. The air near the floor remains cooler, causing discomfort and prompting users to raise the thermostat, which increases heating costs. In contrast, the Röpiss emits radiant heat, warming objects and surfaces in the room directly, including floors, walls, furniture, and even people. This process allows for a more even and comfortable temperature distribution throughout the space. Because the Röpiss operates as a massive thermal battery, absorbing and gradually releasing heat, the temperature in a room heated by a Röpiss remains stable, with minimal fluctuations. Despite its remarkable efficiency and the comfort it provided, the Röpiss faced a decline in the 19th and 20th centuries. Several factors contributed to this trend. As coal, oil, and natural gas became widely available in the 19th and 20th centuries, the economic incentive to conserve wood diminished. With the advent of cheap energy sources, many households opted for simpler heating solutions, such as cast iron stoves, which could be installed for a fraction of the cost of a traditional Röpiss. With energy costs low, few people prioritized efficiency, leading to a decline in the use of masonry heaters. The construction of a Röpiss is labor-intensive and time-consuming. It requires skilled masons to understand the intricate channel system, as well as proper foundations to support the substantial weight of the stove. In contrast, modern furnaces can be installed quickly, often in just a few hours, making them more appealing to homeowners seeking immediate solutions. Between 1950 and 1960, thousands of kakaloon and Röpiss were removed from Swedish homes to accommodate radiators and baseboard heaters, further contributing to the decline of this efficient heating technology. Modern construction standards in many Western countries were developed around forced air and hydronic heating systems. While masonry heaters are still legal, they often exist outside of standard frameworks. Most building inspectors and HVAC contractors are unfamiliar with how to size or install them correctly, leading to a further decline in their use. The institutional knowledge that once made Röpiss standard in every Swedish cottage has faded, and with it, the understanding of their benefits. Despite the decline in the use of Röpiss, modern society is beginning to recognize the advantages of this ancient technology. As energy costs rise and concerns about climate change intensify, more people are seeking sustainable and efficient heating solutions. The Röpiss represents a return to a more sustainable way of heating homes, one that utilizes a renewable fuel source and minimizes energy waste. Today, many are rediscovering the benefits of masonry heaters. The Masonry Heater Association of North America maintains a directory of certified builders, and organizations dedicated to building preservation in Sweden are teaching traditional Röpiss construction methods. A modern masonry heater based on the same principles as the Röpiss typically costs between $5,000 and $15,000, depending on size and finish. While this may seem steep, it is essential to consider the long-term cost savings associated with operating a masonry heater compared to a traditional furnace. A well-built masonry heater has no moving parts, no filters to replace, and no electrical components that can fail. Its lifespan is measured in centuries, not decades. The cottages in Småland serve as living proof of this durability, standing strong after generations of use. For those interested in building their own Röpiss, the materials are not exotic or hard to find. Standard fire bricks for the firebox, regular bricks for the channel system, clay mortar for the joints, and a damper to regulate draft toward the chimney are all readily available. Plans and resources for constructing a Röpiss are well documented, allowing individuals to take on this project themselves. However, it is essential to approach construction with care, ensuring a proper foundation and understanding the sizing of the channels relative to the firebox. While the Röpiss offers many advantages, safety should always be a priority. Due to its substantial weight, a Röpiss requires a proper foundation to prevent settling or structural issues. It should rest on a masonry or concrete base capable of supporting the load. Additionally, the chimney connection must be correctly sealed and maintained to avoid leaks that could pose safety hazards. Regular inspections are crucial. Swedish builders historically check their Röpissar through soot doors to ensure proper functioning, and modern users should adopt this practice as well. A cracked flue channel can lead to dangerous carbon monoxide leaks. Understanding how to maintain and inspect the Röpiss is essential for ensuring a safe heating environment. The Swedish peasant sitting in his log cottage in 1785, warming his hands by a Röpiss he built from local brick and river clay, was not living in the past. He was utilizing a heating technology that modern science has confirmed as one of the most efficient wood-burning systems ever designed. With just 2 hours of tending to the fire in the morning, he could stay warm throughout the day and night without drying out the walls or compromising indoor air quality. His only fuel bill was a stack of birch logs he cut himself, an economical and sustainable solution. In contrast, today's typical heating systems often waste a significant portion of their energy, leading to high bills and uncomfortable living environments. As we confront rising energy costs and increasing environmental concerns, the Röpiss offers a glimpse into a more sustainable and efficient future. By embracing this ancient technology, we can not only honor our past, but also pave the way for a cleaner, more efficient, and more sustainable approach to heating our homes. Until next time, stay warm.